We're on page 27 of our Exponents Manual, Exponential Regression. Data. The data at the right shows the cooling temperatures of a freshly brewed cup of coffee after it is poured from the brewing pot into a serving cup. The brewing pot temperature is approximately 180 degrees Fahrenheit. So right here we have our table with the time in minutes and the temperature in degrees Fahrenheit. So go ahead and write down these calculator notes for your TI Nspire. This is the steps to put this into the calculator. Exponential regression. Part A. Determine an exponential regression model equation to represent this data. So let's go ahead and go through the steps on how to put this into the TI Nspire. So first you turn your calculator on, go to this icon right here. It says add lists and spreadsheets. Now we might have more than one tab open. If that's the case, press Control up and keep deleting until it says OK. Go back to the home, press the add lists and spreadsheets. Let's go ahead and call column A X and call column B Y. From here, we're going to go ahead and copy all of our values in the table for the first column. So let's go ahead and do that. So we have 0, 5, 8, 11, 15, 18, 22, 25, 30, 34, 38, and so on. When you're done with that column, you're going to go over to the next column and copy all the y values down. So 179.5 and so on. And when you're finished, always double check to make sure that all the stats are correct. It would be obvious that if you may have missed one if the two columns were not the same length. So after you do that, you're going to go ahead and highlight the first white box in column C like this. And then you're going to press Menu for Statistics, 1 Stat Calculations, and then A, Exponential Regression. Press right again, choose the X. Go down, press down again, and then press right. Choose the Y, and then press Enter. You should get the exponential regression. It looks like this. We have A, B, R squared, and R. So using the A and the B, we could go ahead and write our equation to model this data. You would round to 1 decimal place, 2 decimal places, something like that. So here's what the equation should look like. T of t equals 171.5 times 0.988 to the t power. B, Compare and contrast the R for exponential, linear, and quadratic. Which is the best fit for this data? So in addition to our correlation coefficient R, let's go ahead and also list our determination coefficient R squared. And for quadratic, there is no R. There's only R squared. So let's first find our exponential one. Well, R is negative 0.985. And our determination coefficient R squared is 0.97. Okay, let's find our linear. So to do that, let's go ahead and scroll until we get to the first white box in column F. We press Menu, 4 Statistics, 1 Stat Calculations, and then 3 Linear Regression. Okay, press right again, choose X, click down again, click right, choose the Y, press enter. Now we have the linear regression as well. So we write our R and our R squared. Okay, from here we're going to do our quadratic regression. So we're going to scroll until we're on the first white box of column I. So press Menu, 4, Stats, 1, Stat Calculations, and then 6, Quadratic Regression. Scroll right, find X, down, right, choose Y, enter. Okay, now you have your A for ax squared plus bx plus c. Okay, our determination coefficient is about 0.997. So the best fit for the data in this case would be exponential. Now what would that be? Well, although the coefficient is at closest to 1, we know that quadratic will eventually go back up. And from experiences, temperatures, when they're cooling, when time goes on, the temperature's not going to go back up. So the temperature will not go back up. And R is closer to 1 than the linear one. So C, based upon this equation, what was the initial temperature of the coffee? So let's go ahead and plug that in. F of 0 equals 171.5 times 0.988 to 0 power. So let's go ahead and put that in our calculator. Let's go calculate. So we have 171.5 times, and then the caret, 0 power. We just have 171.5. This degrees Fahrenheit. How about when is the coffee at a temperature of 106 degrees? So we're going to have it equal to 106. Okay, let's zoom out. Okay, so menu, trace, graph trace. Keep scrolling until you get 106. Okay, f of t equals 106 when t equals 40. And it's 40 minutes. Okay, what is the predicted temperature of the coffee after 1 hour? So we're looking for f of 60. So you can either plug this in on your calculate or you can use your graph. So we can keep scrolling until we get to 60. So it looks like we have about 83.1. So that's how you would do regressions in the TI Nspire.